Welcome to the deep dive. Okay, we are plunging into the, wow, incredibly fast-paced world of AI innovation and coding.
It really is moving quickly.
Yeah, it feels like every few months, maybe even weeks, a new tool pops up. GPT-4o, Claude Code, DeepSeek V3.
Always something new on the block.
And while they're all genuinely impressive, they often feel like they just spit out neat snippets, right?
Yeah.
Yeah.
They give you pieces, useful pieces sometimes, but pieces nonetheless.
Exactly. They give you the ingredients, but you're still, cooking the meal. You get a function here, maybe a class definition there, but you're still doing most of the heavy lifting. Have you seen anything recently that's really challenging that whole paradigm?
Absolutely. And that's precisely why Alibaba's Qwen3 coder is getting so much buzz right now.
Okay.
This isn't just another code generator. This model, it really feels like it changes the game because it doesn't just generate functions. It actually plans, executes, tests, refactors,
Wow.
and keeps going until the job is actually done.
So it's more like an agent.
Exactly. Think of it behaving like a true AI coding agent, capable of holding a screwdriver instead of sketching one. That analogy, I think it really nails the shift.
Okay, I like that. A screwdriver, not a sketch.
Yeah, it's moving from a model that describes a solution to one that can actually implement it, systematically hitting all the steps an experienced engineer would.
Right. So our mission for this deep dive seems pretty clear then. We need to unpack what makes Qwen3 coders stand out.
Yeah.
Where does it really rank against the other big players? How does its open release change things for open source AI?
That's a huge point, the open release.
And maybe most importantly, what does this all mean for you listening right now? Whether you're a developer, maybe an enterprise leader, or just someone, intensely curious about where AI is headed.
Okay, let's dive in.
So when you look at many of the current large language models, they can sound, well, absolutely brilliant at first. They talk a great game about code.
They can be very convincing.
But then they often just sort of collapse when forced to run their own code.
Right.
They hallucinate imports, miss edge cases.
Forget to close files, yeah.
Yeah.
All the classic mistakes.
I think of them as maybe the bright intern at a whiteboard. Full of ideas, looks great on paper, but maybe not quite ready for production code.
That's a really good analogy, actually. The whiteboard warrior.
So how is Qwen3 Coder getting past that common pitfall?
Well, that's exactly where Qwen3 Coder moves the goalposts. It's not just about sounding smart. It's built for doing.
Okay.
Under the hood, it's a massive 480 billion parameter mixture of experts model, MOE, and it uses about 35 billion active weights for each token it processes.
Wow, 480 billion, that's huge.
It's serious compute, and this architecture gives it a depth that allows for genuine agency. It can spit up a REPL.
A read evil print loop, right, so it can run code itself.
Exactly, an interactive environment. So it runs its code, then it can feed its own code through a linter, catch exceptions, and then patch those bugs.
Without a human stepping in.
Without human nudging. Think about that for a second. It's self-correcting, basically in real time.
That's a big step.
It is. And beyond just fixing its own mistakes, it can look at a pull request, really parse it, weigh the risks of the changes, and then suggest the safest way to merge it.
Yeah.
And what's really remarkable is its memory.
The context window.
Yeah. It can handle 256,000 tokens natively.
Okay, that's already pretty large.
Right. But it can stretch up to 1 million tokens with some clever extrapolation tricks.
1 million tokens. That's an entire code base, potentially.
Exactly. It can remember entire repositories, understand the whole scope, how everything connects. As the source material aptly puts it, that package turns the model into a seasoned engineer who brings a checklist, not a coloring book.
A checklist, not a coloring book. I like that. It implies process, discipline.
Exactly. It's not just drawing pictures. It's building things and systematically checking its work.
That's a really powerful analogy. But, okay, to be a true seasoned engineer, surely it has limits too, right? I mean, where do we still see human engineers as indispensable compared to Qwen3 coder?
Oh, absolutely. You're right. Human ingenuity, especially when it comes to really abstract problem solving or genuinely novel system design, that's still paramount. But Qwen3 coder does significantly narrow that gap.
Okay. So how does an AI even learn these kinds of, senior dev behaviors? It's one thing to generate a snippet of code, but understanding context, executing, self-correcting, that feels like a massive leap. How do they train it?
Yeah, it's a great question. And its ability to learn these things really comes down to a highly advanced training approach. Alibaba basically skipped the synthetic kind of toy tasks that a lot of models train on.
Right, the simple stuff.
Instead, they used reinforcement learning, but pointed it at genuine issues, scraped directly from real-world code repositories. Think GitHub issues, leak code problems, code forces competitions.
So it learned from actual problems developers face.
Precisely. This means the model learned to value past tests over pretty pros. It wasn't about generating code that looked nice. It was about generating code that worked, that passed the unit tests.
Function over form, in a way.
You could say that. And on the back end, they had this swarming fleet of 20,000 parallel environments on Alibaba Cloud, just relentlessly hammering each candidate policy, each version of the model, until it converged.
20,000 environments. Wow.
Yeah. So the result is a neural network that really trades chatter for unit tests. It's built for execution, not just talking about code.
That's fantastic context on its core capabilities and training. But, how does all this theory actually play out? Does it work in practice? Do the sources give any, concrete examples of it doing the work, maybe compared to other models?
They absolutely do. And this is where it gets really interesting. The sources talk about this Pomodoro build-off test.
Okay, a Pomodoro timer, like the productivity technique.
Exactly. They asked different models to create a simple browser-based Pomodoro timer, just, basic HTML, CSS, JavaScript.
Right, a common enough little web app task.
And this is where the rubber really hits the road. Yeah. When you compare the results from that test, the differences are pretty stark.
How so?
So Qwen3 Coder, it didn't just scaffold the basic HTML, CSS, and vanilla JS. It actually added a work break toggle switch.
Which wasn't even asked for.
Never requested.
Yeah.
It also wired up keyboard shortcuts and shipped a tidy UI that was responsive, fitting bootstrap breakpoints. This kind of proactive streak, it echoes what Andre Carpathy calls feature scent. It anticipates user needs. That's remarkable for an AI.
Okay, that is impressive. What about the others?
Well, Claude Code, it produced functional code, sure.
Okay.
But it skipped the responsiveness aspect, offered no extras, just the bare minimum requesting.
Oh, GPT-4o.
GPT-4o delivered clean markup, looked nice, but it failed to debounce the start button.
Ah, so if you clicked it fast.
Yep, the timers would double up, triple up. A common rookie mistake, maybe, but something Qwen3 caught or avoided. So the core difference shown here really clearly is, well, the source says it best. That is the difference between generate and do.
Generate versus do, that's a huge distinction. It really shows that agency you mentioned.
Exactly. Foresight, initiative.
Yeah.
It's a step beyond just following instructions.
Okay, that's a compelling anecdote showing the do factor. But anecdotes only go so far. I'm curious about the hard data. How does it stack up on, the rigorous public benchmarks?
Right.
The sources mention LiveCodeBench from vals.ai. They call it the toughest public arena for autonomous coding agents. Apparently, it doesn't just score snippets. It forces models to read prompts, plan algorithms, write runnable solutions, and pass hidden test cases.
Yeah, it's a serious gauntlet.
Like the Formula One grid for AI developers.
Yeah.
So if Qwen3 Coder is such a game changer, where does it actually land on that leaderboard? Is it number one?
Well, this is where it gets really interesting and maybe a bit counterintuitive at first glance. Qwen3 Coder is actually parked in 7th place.
7th. Okay, that doesn't sound like market disruption initially.
Right. But what's fascinating here is that the raw accuracy score alone, it kind of hides the strategic upside. We need to learn how to read this leaderboard like an engineering manager signing the checks, basically.
Okay, so look beyond just the rank number. How do we do that?
We need to look through 3 critical lenses. And when you do that, the picture shifts dramatically.
Lens number 1.
First, the cost-performance ratio. Accuracy matters, obviously. But output tokens, those are what actually cost money, what pays the server bills.
Right.
Qwen3 Coder produces 1 million output tokens for just $0.88.
88 cents per million tokens. That sounds cheap.
It is incredibly cheap.
Yeah.
Now compare that sharply to something like, say, Claude Opus 4. Same job, 1 million output tokens costs $75.
$75 versus 88 cents? It's
85 times more expensive for the output, as the source puts it quite vividly. Opus costs a mid-sized car each quarter. Qwen3 Coder costs a team lunch.
Wow.
Think about enterprises running nightly builds, maybe spitting out 20 million tokens a night. That cost difference isn't just incremental, it's transformative.
That makes sense. Okay, lens number 2.
Second is the latency trade-off. We have to acknowledge Qwen3 Coder isn't the fastest. Its latency is measured at 429.48 seconds. So almost 7 minutes for a complex task on the benchmark.
7 minutes. Yeah, that feels glacial, as the source says, if you're trying to debug something right now.
Exactly. For real-time interactive pair programming, just probably too slow. but for asynchronous tasks,
Hmm.
like overnight refactoring jobs,
Ah,
Spark
oh,
batch documentation runs, or automated pull request triage. For those kinds of tasks, that latency is actually fine.
because it doesn't matter if it takes 7 minutes or 10 minutes if it runs overnight anyway.
Precisely. In that world, the massive price difference completely overwhelms the time difference. So yeah, for instant help, you might still use something like GPT-4o Mini, but for that back-office grunt work, you pick the cheaper marathon runner.
The cheaper marathon runner.
Got it.
And the third lens.
And third, maybe the most crucial for many, open source superiority. Every single model ranked above Qwen3 Coder on that leaderboard. They're all proprietary, closed source.
Ah, okay. That is a big deal.
It's critical if your business needs on-premise inference, maybe for security or data residency, or if you need strict privacy guarantees, or if you need to fine-tune the model on your own classified internal code bases.
Those closed models are useless to you.
They're non-starters, exactly. So if we connect this to the bigger picture, Qwen3 Coder suddenly looks very different. It's the highest-ranking open model on the hardest public benchmark.
So it's effectively #1 in the self-hosted league, as the source puts it.
That's a perfect way to summarize it. First place in its league.
Okay.
So when you look at that table through these three lenses, cost, latency trade-off, and open source, it doesn't show a middling performer at all. It actually reveals a market disruption.
Right, because it's hitting that sweet spot.
Yeah. Exactly. Qwen3 Coder lands within 13 accuracy points of the frontier. So it's close to the top performers in raw skill, while slashing output prices by 2 orders of magnitude and flying the open source flag.
That combination, yeah, that's powerful.
It turns what was maybe a luxury capability, affordable only by big tech, into a commodity tool. It fundamentally changes what's possible for startups, for enterprises with specific needs, and definitely for researchers. It offers power, cost-effectiveness, and flexibility.
That's a fantastic reframing of that leaderboard data. It really highlights that context is everything. It's not just about the raw score.
Not at all. It's about the practical value equation.
And speaking of practical, let's boot up reality, as the source says. They apparently dove into 5 really messy problems that were thrown at Qwen3 Coder during actual field tests, running on a single H100 GPU box, I think.
That's right. Real-world scenarios, not just benchmarks.
So what did those sprints reveal about its true capabilities when things got, messy?
Yeah, these field tests really hammered home that do factor we talked about. For example, one task was to refactor a legacy payment gateway.
Oof. Legacy code. Always fun.
Tell me about it. This was a Java monolith using old SHA-1 signatures. You can almost hear the groans from any developer asked to touch that kind of thing.
Definitely. So how did Qwen3 do?
It parsed 9 interconnected Java packages, figured out where the SHA-1 was used, swapped it out for SHA-256, untangled some brittle reflection hack they found,
Wow.
and even wrote 3 new JUnit tests to prove the changes worked. It ran the Maven build twice to show green checks.
That's comprehensive. How did it compare to others?
Interestingly, the source notes GPT-4o did a similar job and actually did it faster, but it left behind a deprecated import statement that would break the build in a newer Java version. Qwen3 Coder avoided that. It produced cleaner, more future-proof code in that instance.
Ah, so speed isn't everything. Correctness matters more.
Especially with legacy systems. Another really cool example was auto-generating REST documentation.
Okay, API docs, another often tedious task.
Exactly. They pointed it at 47 fast API JSON endpoints. Qwen3 Coder crawled every decorator, figured out the schemas, built a correct OpenAPI 3.1 specification file,
Nice.
and then generated human-readable Markdown documentation for all of it. The whole process took 12 minutes.
12 minutes versus, what, half a day for a human?
Easily.
Yeah.
Maybe more, depending on complexity. And Claude Code apparently needed a second pass on this one because it missed some of the nested data schemas initially. Qwen3 got them right on the first try.
Okay, another point for robustness. Any other standout?
Yeah, one on teaching SQL by example.
Yeah.
They asked it to create an interactive tutorial explaining the difference between groupie bias subqueries and SQL window functions, something that trips up a lot of learners.
Definitely. How did it approach that?
Instead of just text, Qwen3 Coder generated a whole Jupyter notebook. It had runnable PostgreSQL code snippets for both approaches. It even used the explain analyze command to show the query plans and timings.
Oh, that's smart.
And then it plotted the execution times using matplotlib, the Python plotting library, so it visually explained the performance difference, which is way better than just vague text descriptions, like what GPT-4o apparently produced for the same prompt.
That's genuinely useful teaching material. One more.
One last one worth mentioning. Automated pull request triage. Imagine a busy repo getting, say, 10 PRs a day.
Yeah, that needs managing.
So they task Qwen3 Coder with labeling PRs, assigning reviewers, checking if tests were included, commenting if not, and even merging trivial changes.
Okay, that's like having an automated maintainer assistant.
Pretty much. The agent cloned the repo, checked the diff stats for each PR, used the GitHub GraphQL API, which is the advanced way to automate GitHub,
Uh-huh.
to set the right labels, bug, feature, needs tests. It successfully merged 2 trivial PRs that just updated dependencies, and it opened review discussions on 3 others that lacked tests, posting clear markdown comments explaining why.
And did it just do it?
Crucially, yes. The source highlights that Qwen3 Coder followed instructions without backtalk. Apparently, Claude Code, in a similar test, refused to perform the automatic merge, citing safety concerns, perhaps. Qwen3 just did the job as instructed.
Following instructions is key for automation. So, summing up these field tests.
Yeah, the key takeaways are pretty clear. Qwen3 Coder really excels when the task is open the hood, twist bolts, rerun tests, the real engineering work.
Right.
Its long context window means it gets the full picture of the code base, so it rarely loses track of variables or dependencies across files. Latency, yes, that's the tax you pay for interactive stuff.
But for overnight jobs.
It rules for overnight refactor jobs, documentation, that kind of thing. It writes fluent English comments sounding like a, mid-career engineer, not just a dry textbook. And that cost per million tokens stays incredibly low.
Say bottom line.
It basically replaced half a sprint's grunt work with a few prompts and pacing coffee breaks.
Half a sprint's worth of grunt work. That sounds like a dream for any dev team, honestly, especially tackling those tedious, time-sucking tasks.
Absolutely.
You've painted a really compelling picture of its strengths there. But, with any new tool, especially one this complex, tackling messy problems, there must have been some, I don't know, surprising weaknesses or unexpected hurdles the team hit during these tests. It can't all be perfect, right?
You're right. It wasn't all smooth sailing. And importantly, the sources do mention the pain points and, crucially, how they were addressed.
Okay, like what?
Well, for instance, they noticed really long latency, like way longer than 7 minutes, on the very first response when the context size got huge, like over 200,000 tokens.
The initial processing load.
Exactly. So the solution was to pre-chunk the repository, basically feed it in smaller relevant bits first, and then only stream the necessary code diffs. That apparently dropped the first response latency from around 420 seconds down to just 70 seconds, much more manageable.
Smart workaround. Anything else?
They also saw it occasionally hallucinating imports, like pulling in obscure Python libraries that weren't needed or maybe didn't even exist. Phantom imports.
Okay, how'd they fix that?
They added pipcheck, the command that verifies installed packages and their dependencies, right into the reinforcement learning feedback loop. So they essentially taught the model to stick to standard libraries unless it was explicitly told to use something specific.
Teaching it constrained. Makes sense.
And one more. Sometimes they got a bit too enthusiastic with auto-refactoring, maybe trying to clean up old, obsolete legacy files that shouldn't be touched.
Right, you don't want it breaking things by helping too much.
Precisely. So they solved that using scope prompts. They'd give it the task, but also provide a specific file out list, maybe as a JSON input, saying only touch these files. That kept it focused.
Okay, so manageable issues with practical solutions found. What about the flip side? Any unexpected positives or thrills, as the source puts it?
Oh yeah, there were definitely thrills too. The agent quickly learned the team's specific Git hooks.
The automated checks that run before commits or pushes.
Exactly. Which meant that the pull request it generated started arriving with green checks on the very first push. No back and forth fixing linting errors or failed tests. That's a huge time saver.
Definitely smooths the workflow.
It also started writing migration documentation while the tests for the migration were still running in parallel. Saved the team an afternoon of tedious technical writing.
Nice bit of multitasking.
And maybe the most impressive stat. Internally, on their own bug fix tickets, it achieved an 88% pass rate on the first try, meaning 88% of the time the code it generated fixed the bug correctly without needing any revisions.
88% first pass success. How does that compare?
Apparently, that beat GPT-4o by 6 percentage points on their internal benchmark. That's a significant win for real-world internal productivity.
Wow. Okay, that is genuinely impressive. It's clearly not just for, traditional coding tasks either. The sources mentioned going beyond coding. Were there any particularly unexpected or innovative uses for Qwen3 Coder that popped up?
Absolutely. Its capabilities seem to stretch into related technical domains quite effectively. For instance, data engineering.
How so?
You can apparently feed the agent a database schema, say from Snowflake, and it can write the corresponding incremental ELT jobs, extract, load, transform, for an orchestration tool like Airflow. It handles the complex data pipeline logic.
Okay, that's useful for data teams. What else?
DevRel blog generation. Developer relations teams often need to write change logs or blog posts about new features. You can just point Qwen3 Coder at a pull request diff.
And it writes the blog post.
It generates a markdown changelog complete with nicely formatted code examples ready to be dropped into a technical blog post. Saves a ton of time summarizing changes.
I could see the appeal there. Security.
Yeah, security audits. It can scan infrastructure as code files, like Terraform. It can automatically flag insecure configurations, like publicly accessible S3 buckets.
Right, a common vulnerability.
And then it can even auto-patch those Terraform files to apply least privilege access policies. That could significantly speed up security reviews.
Streamlining security, that's valuable. Anything else?
Education, too. Instructors could use it to generate dozens of slightly different programming assignments based on a template. Each variant could come with its own hidden test suite.
Okay.
And then the same model could potentially be used to grade the student's submissions against those hidden tests. That's a potential game changer for scaling coding education. It's a remarkably versatile agent, well beyond just writing application code.
It really sounds like it. Okay, so we've heard the theory, the benchmarks, the field tests, the potential. Let's bring it home. What does this all mean for your workflow, for the listener? This is where we shift from the impressive capabilities to how you can actually put Qwen3 Coder to work. What's the practical guide here?
All right, let's get hands-on with the practicalities. First off, hardware. What do you need to run this thing?
Yeah, good question, especially that 480 billion parameter model.
Right. So if you're just solo tinkering, exploring it, the recommendation is something like an NVIDIA RTX 4090 GPU that has 24 GB of VRAM. You'll probably want 64 GB of regular CPU RAM too.
Okay, a high-end consumer card, manageable for enthusiasts.
Exactly. For more serious development, maybe running it constantly, an H100 GPU with 80 gigabits of VRAM is better. And if you're thinking clusters, deploying it at scale, then you're looking at multiple cards, maybe like 8X MI300X GPUs, which have 192 gigabit of VRAM each.
Serious hardware for serious use. What about memory needs?
Well, using 8-bit quantization, which slightly reduces precision but drastically cuts memory, helps a lot. That roughly has the memory requirements. But if you want the full precision of the big 480B model, you'll need around 200 gigabytes of VRAM available.
Okay, that puts it firmly in the data center category for full precision. How do you actually run it?
Several ways. For running locally on your own machine, probably the easiest way is using Ollama.
Ollama, right. That's the framework lots of people use for a local LLM.
Yeah, it's super popular, easy to use. You just type Ollama pull Qwen3 coder.8bit to download the quantized model, and then Ollama run Qwen3 coder to start chatting with it.
Simple enough. Can you use it in your editor?
Yep, there are integrations. For example, you can hook it up with VS Code using extensions like Continue, so you can get suggestions right there in your IDE.
Okay, what about hosting it yourself, maybe for a team?
If you want to self-host, say for internal use, you can use Hugging Face's libraries combined with Docker. You'd typically spin up a VLLM endpoint.
VLLM, that's the fast-serving engine for LLMs.
Exactly, highly optimized. And that gives you an API endpoint compatible with the Qwen3 API. Perfect for building internal Git bots, maybe private Slack apps that use the model.
Or you can just use their cloud service.
Right, you can simply call the managed Qwen3 API provided by Alibaba through Scope. The nice thing is, it's compatible with existing OpenAI API workflows. So if you're already using code that calls OpenAI, you often just need to change the API endpoint and key. No new SDKs required.
That lowers the barrier to entry. What about customization? Fine-tuning.
For fine-tuning on your own private code, your private repos, the recommended approach is using PE50 parameter-efficient fine-tuning, specifically with LoRa adapters.
LoRa, right, those small adapter layers.
Exactly. These adapters are relatively small, maybe just a few hundred megabytes. So you're not retraining the whole 480 billion parameters. You train this small adapter on your specific data. It's much more efficient, faster, and easier to manage than full fine-tuning.
Okay. And cost. You mentioned it's cheap, but what's the official pricing structure?
The pricing is tiered based on usage, naturally. But the really great thing for getting started is that every new account on Scope gets a 1 million token credit, valid for 6 months.
1 million free tokens. That's plenty to experiment with.
Absolutely. It's a fantastic way to kick the tires and see if it fits your needs without any initial investment.
Okay, let's circle back to that latency point. 5 to 7 minutes for the big model. How do you actually work that into a workflow?
Yeah, it's crucial to manage expectations regarding latency versus workflow. We need to reiterate that flagship 480B model, yes, it can take 5, 7, maybe even more minutes to answer a really long, complex prompt.
So not for live pair programming.
Probably not ideal for that real-time back and forth, no. But, as we discussed, it's perfect for nightly CI jobs.
Continuous integration runs.
Yeah. Things like repo-wide refactoring, generating documentation for the whole project, doing bulk pull request analysis or triage overnight, tasks where speed isn't the absolute priority, but thoroughness and cost are.
So you use it asynchronously. Are there ways to make it feel faster?
Yes. For tighter feedback loops, you could use a smaller, quantized version of the model, which will be faster but maybe slightly less capable. Or you could even use a different faster model like GPT-4o Mini as a sort of first responder for quick questions, and use Qwen3 for the heavy lifting. Also, the API supports SSE server-sent events.
Ah, streaming output.
Exactly. So you can stream the tokens back as they're generated, pipe them directly into your IDE or a chat window.
Uh-huh.
It doesn't make the total time shorter, but it makes the perceived performance much better because you see output immediately.
Right, you're not just staring at a blank screen for 7 minutes. Good tip. Any final checklist items before someone deploys this?
Yeah, a few practical tips, a checklist before shipping, if you will. First, always scope the context. Don't feed it your entire massive monorepo if you only need it to work on one module. Chunk it. Avoid paying for processing irrelevant vendor folders or unrelated code.
Makes sense. Control the input.
Second, pin the model tag. Use explicit version IDs like Qwen3 coder.8bit SV1.1 or whatever the specific tag is. Don't just use .latest. This avoids unexpected behavior changes if the model gets updated underneath you.
Good practice for any dependency, really.
Absolutely. Third, stream the output using SSE, like we just discussed, for that better perceived performance. And fourth, log the tool calls. If you give the agent the ability to read files, write files, run commands, make sure you capture those events somewhere. Create an audit trail.
Crucial for security and debugging.
Definitely. But if you follow these steps, manage the latency expectation, leverage the cost, you really could, as the source suggests, hand Qwen3 Coder a 1,000-file legacy code base on Friday and come back Monday to green tests and fresh docs.
That is quite the promise, and it really drives home the point that Qwen3 Coder feels like, well, not just a shiny gadget. It feels different.
Yeah, it feels more like a tectonic plate shifting under the entire software tooling landscape.
Yeah.
It's fundamental.
This seems like it opens up possibilities that were, frankly, out of reach for many people or smaller organizations until now.
And this naturally raises an important question. What's next? Where does this go from here?
Yeah, what's on the horizon?
Well, Alibaba is already hinting at potential smaller MOE descendants, maybe a model with, say, 34 billion active parameters, but built on an 8 billion parameter base. Something efficient enough that it could potentially fit and run effectively on a high-end laptop.
A laptop-capable version. That would be huge for accessibility. When might we see that?
Given the pretty rapid release cadence we've seen with the Qwen family so far, the source speculates we might see something like that drop before the end of Q4 2025, so maybe not too far off.
Okay, interesting. What else?
Meanwhile, there's really exciting research happening around self-improving loops. The idea is you have the agent, like Qwen3 Coder, actually patching its own source code.
Modifying itself.
Yeah. Then it compiles a new version, benchmarks it, sees if it got better or worse, and then uses that feedback to retrain itself to make further improvements.
The recursive improvement cycle.
Exactly. If that research lands successfully and someone integrates it into an open model like Qwen3, we might genuinely witness the first recursive improvement cycle in a freely available model.
Okay.
That's a profound thought for the future of AI development.
That is mind-bending stuff. So, okay, bringing it back to today. For you, the listener, what's the big takeaway here? What does this all mean for you right now?
I think the core impact is democratization through open access.
How so?
Well, startups, for example, can now potentially swap out expensive, closed-source black box APIs for these powerful self-hosted agents. That gives them full control, better privacy, and potentially huge cost savings.
Right, leveling the playing field a bit.
Enterprises, especially those with strict data privacy or regulatory needs, can bake this kind of AI capability directly into their internal pipelines, keeping all their sensitive code and data completely in-house.
Huge for regulative industries.
And students. Think about students learning to code. They now potentially have access to a tireless mentor who never growls at naive questions.
Mm.
It's an unparalleled learning opportunity, letting them explore